you're going to do this dragon genetics. Instead of popsicle sticks, you're going to have these cards. And there's a green chromosome, so you have these dragons. You have these dragons. Thank you. And these dragons have a green chromosome, a yellow chromosome. They have a what? And then they have a X chromosome. And they have two X's if they're a girl. And they have green, regardless, they have the green and the yellow. They're autosomal. That means they're body cells. So they have all their species have the green and the yellow. The females have two X's. The males have an X and a Y. The green chromosome contains, they have two green chromosomes. Two of them. And that green chromosome has a gene. What are the genes on the green chromosome? I believe it's W. What? L. A. C. They have all four of these are on the chromosome. On both their copies. The only question is, do they have uppercase W, the dominant form, or the recessive form? I'm using a little hashtag, a little tag for the little. And dominant or recessive, dominant or recessive, dominant or recessive. I'm only using the hashtag for those that are difficult to tell if it's uppercase or lowercase. They also have, each dragon also has two yellow chromosomes, which have what genotype? What genes? What types of genes? What types of genes on them? What is it? No, genes, the letters.
Oh,
F, T, and R, which again can be lowercase or uppercase, either dominant or recessive. Now there's an exception. Oops, this is a problem. It's not really a problem, but it is a concern. The concern is that T and R are not dominant and recessive. T and R are not dominant or recessive. So here you don't have two phenotypes, you have three possible phenotypes. I'll go over that again in a second. But the point here is that for sure the yellow chromosome has F gene, a T gene, and an R gene on that chromosome. Is that clear? And they have each dragon has two copies. Now the sex chromosomes are a little different. If they're XX, they have two chromosomes. They still have two sex chromosomes. They have two X's. What genes do they have on them? What genes do the XXs have? X have on them? They have H and what? No, just H. It's the only thing they got on the X chromosome is H, either big H or a little h. But the only thing you're concerned with in this activity is there's only one gene on the X. But your girl dragon has two copies, right? So she could have HH, big H, or big H, little h, whatever it is you want, because you're making this dragon. Are we clear? Now, your male dragon has the same chromosomes, except for the sex chromosomes, obviously, because it's male, right? I hope, is that obvious to everyone? Am I making sense? So you still have you still have two greens. So let me circle all the stuff that's the same. So your male dragon, if this is your male, still has all the greens, right? All the same genes, 2 copies of each, all the same yellows, trying to remember that this T and R are very different, and they've actually made that point at the bottom of that paper. Do you see that? They describe it to you. We'll look at that in a second. So all that's the same in both dragons. The difference is that this female dragon has 2 X's, and this male dragon doesn't have 2 X's. They have an X. That's true. They do have 1 X. So they do have 1 copy of the H. They have 1 copy of the H, either big H or little h, whatever one you want, right? It's your male. But then they have 1 copy of the Y, which also has a gene on it. And what's that gene on the Y?
M.
It's an M, either big M, it's only big M. They don't give you a little m, right? Now, interestingly, in humans, it is possible to have a little m. It's actually not an M. It's a gene that codes for androgen. And if you have the Y chromosome, but the gene doesn't work, then you're born a female. So that's interesting. But in this simple case, the dragons either has a big M and they all work. Are we clear? So those are your genes. Now your job, at the beginning, you're going to make each of these. You're going to make squares. You're going to take your squares. On one side, you're going to write, let's say, green. On the other side of that paper, you're going to put the genes on that chromosome. You're going to have 2 greens, correct? Because each parent has 2 greens. I'm going to do the female at this point. I'm doing the female here. So you have 2 green pieces of paper labeled on one side green. They're both labeled green on the other side. On this side, you're going to choose the genes. So how do you do that? Could I see your paper? You're going to choose which. It's your dragon. It's your dragon. You have to partner up. Now you're going to make a baby dragon. You're going to mate your dragons. Is that clear? So the person sitting next to you, or I don't really care who you choose, but I'd rather just do it with the person next to you, just so you don't have to move around. You're going to choose, one of you's going to have to be a female, going to have a female dragon, and the other one's going to have a male dragon. Does that make sense? You got to, because that's the only way to make a baby. Male and female. So if you're a male, then you're going to have to do this for this set of genes, right? Which is everything except for the Y. If you're female, you're just doing this set. Are we clear? All right. So with green, with the green chromosome, you're gonna say, well, I want my dragon to have wings. I like a short neck. So if I wanted to have wings, at least one of them has to have a big W. The other one could be little w. What the heck? Just for fun. This is an example. Is that clear? I want it to have a short neck, so the only way to do that is 2 lowercase l's, because short neck is a recessive trait. I like it completely white, a white dragon with no freckles. So I'm going to have another recessive gene, another homozygous recessive. And it doesn't matter what I'm doing for C. I'll just choose big C, big C. But C is not going to be green. Skin color is not going to be light green. Why? If you read at the bottom, there's little asterisks. If you choose little a, you can't make any pigment. So even if you have the gene for, green, you are, in fact, going to be little a, which is a recessive albinoism. All right, so this just is a master gene that shuts off in a recessive, so you have no pigment anywhere on the dragon, including freckles. That makes sense? So it doesn't matter if you have big C, little c, because the master gene has taken over. Now that's your green chromosomes. The next, you're gonna do the same thing with the yellow, but the interesting thing about the yellow gene, and let's take a look at a yellow gene now. Again, you're gonna take a yellow, you're gonna write it on one side, you're gonna put yellow. On the other side, you're gonna choose your dragon's characteristics, and then that's gonna choose your genotype. So for F, please don't just use fire breathing. Somebody choose non-fire breathing. I personally would rather have a dragon doesn't breathe fire because I would rather not get killed. So by accident, they burp or something and then you're burned up. It's just not cool. So a big F is for fire, and little f is no fire. So if I wanted to choose a fire breathing dragon, I put a big F. I want to be interesting, I put a little f because it's fire. Now, for those with the T and the R genes are weird because they're not dominant or recessive. They're called incomplete dominance. So this is a type of inheritance where you mix the two. The two are mixed. So red and white would get you pink. Tall and short would get you mid-sized, that kind of thing. Somewhere in the middle. So I'm not sure exactly how this is mixed, but let's go ahead and do it according to this. So they go big T, they say is 5 toes. Big T, little t is 4 toes. And little t is 3 toes. So either it's the smallest or the biggest or somewhere in between. So it's a mix. So choose which phenotype do you want? Do you want the 5 toes, the 4 toes? I keep using the word phenotype. I hope that's making sense to you. Is it? So phenotype is what you see. You see 3 toes. You can count them. You don't see the letter on the chromosome. You don't see the combination of nucleotides. Then with incomplete dominance. So then you have big R, which gets you freckles, let's say 10 freckles or something like that. You have big R gets you a lot of freckles. A lot of freckles. I'm going big arrow to write a lot. If you have big R, little r, you have some freckles. Thank you. So just maybe 1, not as many. And then if you have little r, you have no freckles. Same gene, 3 different alleles. That if you get the little r versus the big R versus the heterozygote, each one gives you a different phenotype. Is that clear? Okay. So then you write what do you want? Do you want a 4-toed freckleless dragon? If that's the case, then you're going to want big T, little t, right? Because that gets you 4 toes. And freckleless would be little r. And then finally, you have your two X's. And for the female, you have your X's. I don't know what. Let's use pink again. So you have your X chromosome. And your X chromosome is going to have there's going to be two of them. And it's either going to be a big H for horn on the nose or little h for hornless. So if I don't want my dragon to have horns on their nose, I'll just put little h, little h. Two H's, because you got two different chromosomes. You do the same thing with the male. Hopefully they look different, because just to make it interesting, otherwise it's going to be boring. You're going to take your cards, you're going to flip them over. So this is your male and this is your female. You're going to have this little circle or whatever you want to call it here in the center. And in front of you, you're going to have all your cards flipped over, and they're going to be labeled different labels. Because the only thing you're going to see, you're not going to see the gene, you're going to see whether what? It's a green chromosome or is it a yellow chromosome? Or is it, and there's two yellows and there's two greens. Is it a sex chromosome? Just write the word sex chromosome on the back of your sex chromosomes. Don't write X or Y, because you want all this to be random. The point is you want it to be random. Two greens, two yellows, two sex chromosomes, right? So 6 chromosomes all together. Mix them up, and then your baby's going to get what? How many of each one? How many of each of these is your baby going to get? One of each. One of each gene. So dad is going to make, mom is going to make her egg. So go ahead and make your egg first. I guess that makes more sense than just putting them in the middle. Go ahead and make your egg, and you're going to make your egg randomly. Choose one. Put one green, one yellow, one sex chromosome. Is that clear? So one sex, one green, one yellow, and dad is going to do the same thing. The male dragon is going to do the same thing. Randomly choose it. And then what are you going to do with these are, in the case of the female dragon, that's the egg. And the male dragon, that's the sperm. So what are you going to do with these eggs and sperms? You're going to mix them. You're going to take this one and this one, put them in the center. Now you have a baby, a fetus. Are we clear? The last piece of this is you're going to have to sit down and draw and write out your genotype. It should be easy at this point. Of mother, genotype, of father, you write it down, whatever that is, and then the phenotype. And the genotype, just to be clear, is 2 of every chromosome. 2 green, 2 yellow, 2 sex. So for the mother, it would be whatever you want it to be. I don't really care. All the different genes for each one. So it would be big F, big F, big F, little f, W, hashtag for the lowercase, LL. I'm just making these up. AA, CC, HH, and that's it. Oh, I forgot TT and RR. TT and RR. So that's my female. What would that female look like? There would be a winged, long neck, normal skin color, normal meaning average. Light green or green, dark green dragon. These are things I can see. That's what phenotype means. Things you can see, you can read, you can count, you can tell the color. A fire breather. With a horn on the nose. And it's a female. So no spike. No spike on the tail. The only way you get a spike on the tail is if you're male. So you do the same. Did you see what I just did? Does everybody understand what I just did? This is the phenotype. Where did I get the phenotype? From the genes. I read the genes. I looked at the dominant traits. Big T, little t is, oh, I forgot to put 4 toes and no freckles. Four toes and no freckles. Okay? Remember that there's 2 special situations here. One's in complete dominance. The other's when you have a master gene that's impacted by a recessive trait, in the case of little a. So if you choose little a, that's an interesting situation. So then you take that, and of course you're going to do the same thing, exactly the same thing with the baby dragon, assuming the baby's born, it hatches. Baby dragon is going to have a genotype. What types of genes? Well, you decided that when you made your baby at random. And then what does that baby look like? What's its phenotype? How do you do that? How do you tell? You look at the genotype. Dominant, put that trait down. If it's big T, little t, and it's in incomplete dominance, put that trait down. If the master gene's impacted because it's little a, put that gene, that phenotype down. All right, does everybody get this game, this deal? All right, try to do it, get it done before the end of period. Oh, sorry. Could you pass this out, please? This is my assistant, by the way. She's just saying in here, she usually assists me. You guys can help each other, do whatever. Do you guys know each other? She's a 9th grader, you're 10th or she's 11th grader. She's with Jonathan all the time in the chess team. No?
For this, I can't do it because I don't know which answers I got wrong yet. Because I didn't get my grade.
Let's do a debrief today. Today's what, Tuesday? I have a meeting.
During study hall?
If I'm here tomorrow. Or during study hall, it's fine.
Or is this a separate assignment?
Separate.